Hello everyone, I am Önder Topuz, BVS Cranes Marketing and Business Development Director. As BVS Cranes, we are very happy to take part in Overhead Crane and Hoist Innovation Conference together with many distinguished participants and sponsor companies in our industry. Today we are going to focus on distant remote control systems in steel production process cranes with a BVS design and build casting crane real-life case study. According to a report by OECD, latest developments in steelmaking capacity 2021, global crude steelmaking capacity increased by 37 million metric tons in 2020, despite extremely weak market conditions. Over the past 2 years, global capacity has increased by a total of 73 million tons. Asia and Middle East counted for almost all of that growth. Capacity is expected to continue expanding over the next few years. Many investment projects continue to take place around the world. For example, a total of 45 million metric ton of capacity is currently underway for completion over the next 3 years from 2021 to 2023, while an additional 68 million metric tons are in the planning stages. Should all these projects be realized, global steel making capacity could increase by almost 5% between 2021 till 23. BVS Cranes, being the largest crane manufacturer in Turkey and among the top 5 in Europe, won important contracts in 2020, 21 and 22. From local steel producers and international customers, BVS is well prepared to utilize its great experience, technical capacity, cutting-edge engineering solutions and financial strength for the steel industry with its 2021-23 growth strategy. This presentation focuses on the 350/80/10 ton 5M heavy-duty casting crane designed and built by BVS Cranes for one of the steel industry leaders in Turkey in early 2021 on the southern Mediterranean coast. Crane span is 28 meters, lifting height is 26 meters, crane runway is 316 meters. One of the key aspects of this crane is that it is an R&D project with many innovative and practical features for the customer. BVS Cranes engineering team made it possible thanks to its certified R&D center by the Ministry of Industry and Technology. 350 and 80 ton hoists are positioned on 4 girders separately to optimize minimum distance approaches on both sides and secured ease of maintenance. The system has a fixed operator cabin on the bridge and also controlled at a distance from an independent control room via cameras, capable of running on an automated scheme. The crane has automatic or semi-automatic positioning system, offering 8 different scenarios. Cabin simulation is available in the remote room so that the operator can observe the crane more realistically. In order to ensure continuous production, the entire PLC system has been designed as a one-to-one backup system. Because of the lower elevation constraints of the customer, all equipment and the crane itself, which would normally have larger dimensions, have been designed with a compact structure, taking into account all the safety details without any compromise. Considering the ISO and FEM norms of our crane, although a life expectancy of 12,500 hours is expected, it is designed for a lifespan of 50,000 hours in order to make the working conditions even more safe and reliable. All sheet metals were exposed to lamination tests according to EN 10160 S2E2. All motors have been designed and built with backups. So let's see this beautiful machine and focus more on the remote control system. Distant remote control systems in steel industry process cranes, a real-life case study. BVS Cranes is an research and development center. BVS Cranes project design department has been certified as an R&D center by the Turkish Ministry of Industry and Technology for a long time, meeting some stringent criteria. There is a continuous R&D activity which results in projects like the first Turkish-made shiploader as the one in the photograph. Fully designed and built by BVS engineering team and currently the largest in Turkey with 1,500 ton per hour soda ash loading capacity. It is operative in Derince Port, Marmara Sea since 2018. Another example, 45/5-ton capacity dock crane operating in a dry dock in Turkey as another example of R&D projects. This is also fully designed and built by BVS engineering team. Another R&D project, 250/80/10-ton capacity process crane built for steel production industry. A 50-ton capacity process gantry crane built for steel industry. For cranes, we use different types of crane control systems. Let's remember some of them, like the ones you see in this picture, remote control units, transmitter units. Conventionally, we also use pendant control units, either tied to the cat or independently moving along the girders. Operator cabins are another method that we use to operate cranes. The aim to use distant control systems is simply to keep operators away from the crane, which works under very dangerous and unsafe environments. Therefore, BVS cranes benefits and further develops today's communication technology, which allows the transmittal of data signals at very high speeds, eliminating the need for people to be on the cranes to operate it. The scope of this R&D study consists of controlling two numbers 350/80/10-ton casting cranes. BVS cranes casting cranes, two units working in one hole, built for a major steel industry producer in 2020 and 2021. 2D and 3D design works have been performed by Autodesk, AutoCAD, and Inventor programs. Based on the predetermined PLC communication protocols, convenient Wi-Fi modems have been chosen to allow real-time video transmission. All equipments have been chosen to cope with high ambient temperatures. Cameras have been chosen with specific lenses to allow fast data transmission and to work under tough environmental conditions. Control room is located in a place where it is impossible to see the crane. Therefore, cameras have been placed in different places of the crane, which could send images to monitoring screens located in the control room. The communication between the distant control room and the crane is realized by industrial-type Ethernet-based wireless transmitters and receivers. There are client Ethernet modules and antennas on the crane, and there are access modules and antennas placed in the crane runway hall. The communication of the long distance between the crane runway hall and the distant remote control room has been made possible by using fiber optic cables. Modules have been initially tested by a draft software to check hardware infrastructure and communications between them. Tests have been performed in 3 consecutive stages. At first stage, all movements have been tested with an empty basket, both on the operator cabin of the crane manually and also from the distant control room with cameras for 3 months. In the second stage, only the bridge travel tests have been performed for 1 month. After successful 2 stages in the last stage, bridge, travel, and hoist movements have been combined, and test procedure has been finalized with success. This diagram shows the cameras. The numbers on the top shows the camera codes, and the bottom numbers shows contingency spare cameras located with same angle for every camera. In this page you can see more about cameras and their angles. Some more examples of the camera angles. Top view cameras have sound transmission capacity as well, and inside the electrical room there are some cameras. This diagram shows the system hardware configuration. As you see, there are 18 cameras, and distant remote control room is shown, and all the other elements of the system. This diagram shows system communication configuration designed for 2 cranes at the moment, but allowing future expansion for 2 more cranes. In the remote control room, there is another set of exactly the same operator's seat and operator panel on the crane. The crane operator can manually control the crane by looking at the camera images in the remote control room, as well as using the local operator cabin placed on the crane. There are positioning sensors on the crane. These sensors provide the possibility of using the crane semi-automatically. Accordingly, in semi-automatic mode, the crane operator can manually lift and lower the hook. Crane, bridge, and trolley movements are carried out automatically via software. The locations or stations where the bridge and car movement will be automatically positioned can be selected by the touchscreen facility. In the area where the crane will work, a restricted area has been created with the automatic positioning system, and the borders have been determined. In order for the crane not to go beyond these limits, software studies have been carried out in accordance with safety software and emergency scenarios. A view from the remote control room. This system has improved drastically the working conditions of the operators in heavy industry casting cranes. High technology has been applied in crane automation. This system is one of the leading projects applied in Turkey so far, designed and manufactured entirely with BVS Cranes' intellectual and financial resources. Crane operator at work in his comfortable and safe environment. Casting crane at work. Special thanks to BVS Cranes engineering and sales teams and our customers. Thank you. Thank you for watching our presentation. We hope to see you again in next event. Goodbye.